Hey everyone, I'm Nitya here with an interesting topic today called LENET-5 architecture from deep learning. Let us go into the history of LENET-5. LENET-5 was introduced in the research paper called Gradient-Based Learning Applied to Document Recognition in the year 1998, which was proposed by Jan LeCun and other three authors. They use this architecture for recognizing the handwritten and machine-printed characters. It is a multi-layer convolution neural network used for image classification. It was a simple and straightforward architecture, that's why it became very popular. Let us learn about the LENET architecture. Technically, it has 7 layers in which 3 convolution layers are there, 2 subsampling or average pooling layers and 2 fully connected layers. In detail, we have 3 convolution layers, 2 subsampling layers, 1 fully connected layer and a softmax layer. Tan-H is used as the activation function. Coming to the first layer, the input picture is taken of size 32 by 32. Convolution kernel size is 5 by 5. Kernel is nothing but the filters applied, and the number of filters which were applied are 6. You may be wondering, what is this feature map? Feature map is nothing but the output of that convolution layer. Then what is this 32 minus 5 plus 1? It is a formula to calculate the output size. How is it calculated? It has a formula n minus k plus 1. So here n is the size of the input picture and k is the size of the kernel. So 32 minus 5 plus 1, we got 28 by 28. The size of the feature map is 28 by 28 and the number of neurons were 28 into 28 into 6. Coming to the average pooling layer, the input size was taken from the previous layer, which is 28 by 28. The sampling layer is the matrix taken as the input, which was 2 by 2. And the sampling type was 6. Here the output feature map is 14 by 14. 28 is the size of the input. So 28 by 2 is 14. Coming to the third convolution layer, the feature map combinations were taken from the previous layer. Here the kernel size is 5 by 5. The convolution kernel types were used 16 and the output feature map we got as 10 by 10. So the number of neurons are 10 by 10 by 6, 10 into 10 into 16. So coming to the fourth layer, which is an average pooling layer, here the input size is taken from the previous layer, which is 10 by 10, and again this the matrix used was 2 by 2 and the output feature map is 5 by 5. So the total number of neurons were 5 by 5 by 16. Coming to the last layer of the convolution layer, the input picture size was taken from the previous layer. All the 16 feature map combinations in the S4, which is the previous layer. The kernel size is again 5 by 5 and the kernel types for 120. Here the output we got is 1 by 1. So here it is a pictorial representation. As I said, it is used for this architecture is used for handwritten digits. So I have here in the example, I have taken 3 as a handwritten character. It is 3 is passed, a grayscale image of 3, and the output is 0. So at the end of this we get 10 classes, which these 10 classes are from 0 to 9, numbered from 0 to 9, which represent the digits from 0 to 9. So if you give any input from 0 to 9, it will classify like in which class it is there. Suppose we have given 3, now it has given 0 in the place of 3, which means it belongs to the class 3, which means the digit is 3. So this is how this works. So this is a summary of what we have learned. Here in the last input layer, we have used softmax as the layer and the size is 10. So 10 means, as I have said, the class is from 0 to 9, which represent each digit. So coming to the summary, we have 5 layers with learnable parameters. The input to the model given is always a grayscale image. It has 3 convolution layers, 2 max pooling or average pooling layers, 2 fully connected layers with a softmax classifier. The trainable parameters given were 60,000. So this architecture can be applied to a dataset like this called the MNIST dataset, which contains 70,000 images of the handwritten digits from 0 to 9, which has each image of size of 28 by 28. Here we have 60,000 training samples and 10,000 testing samples. Here is the example of how the dataset looks. Let's get into the coding part of LENET-5. So here we use TensorFlow and Keras as the libraries, and the model used is sequential model. Coming to the first layer, the kernel type is 6 and the size is 5 as discussed. The activation layer is tanh. Coming to the second layer, we have used average pooling 2D, which comes in Keras library. In the same way, we have defined the up to 5 layers. And what is this flatten? Flatten means suppose we have a pooling layer of kernel type 3. It is flattened and it is converted to a neural network like this. Then it is sent to then it becomes a fully connected layer. So here we use tens and we get 84 nodes, and then further it is converted to 10, and the activation function used is softmax. So this is about the LENET-5 architecture. Hope you like this video. Thank you.